So there's been a lot of confusion about function block, and I personally like function block because it's very visual and it's a good alternative to ladder logic because some things are a little bit harder to do in ladder logic. But again, this is a tool in your toolbox. And to start out, main routine is usually set up in ladder logic, and so if you're going to call a function block, you're going to have to create a subroutine. So we're going to right click on main program, go to add and new routine. At this point, you need under type, you need to change to function block diagram. Give it a name. I'm going to just call it FBD because why not? And hit OK. For you to actually, for this program to actually work, you're going to need to call rung and put in jump to subroutine. I'm lazy. I just type in JSR and go ahead and call that function block, and that's all what you need to do in the main program. Function block is a little bit different than ladder logic. It is a lot more visual. And you can see, and let me shorten this up a little bit. You can see that it's a big white open blank space because you are to create something. The biggest confusing thing is if I go into main routine, and if I do a simple program, so say I'll do this here. This is a simple and program. So start, stop, and light, and just light one. Okay, we forget that this here is the tag, and this here is the instruction. Let me erase that. But we forget that the XIC is the instruction. That's the logic that we're execute. Was just saying, hey, examine if this is on, or examine if this is off. Is this a 1 or 0? And then this is the tag. This is the name that we want to evaluate that instruction by. And that's the same for all of this. If I want to turn this into function block, the same what I would need to do, and you can navigate through here. I find it easier to right click and add element because then it gives me a little search bar. But remember, that is an AND command. Well, I'm going to use a BAN command, a Boolean algebra. And this would be the same thing as what I just did over there, except for one big difference. The rung and the instruction is all embedded in this block, and I can edit it. Anytime you see these 3 little dots, that means you can edit the properties of this instruction. I can show more things or hide more things. I can have it execute on certain conditions. So why not? I might just, so I'm not going to do that here. I would do that another thing, but here's the 2 ins and the 1 out because and both need to be true in order for this to work. And these here are what I would utilize, my input reference and my output reference. This is just a fancy way of putting in your tag. I can drag this down, and again, I can just put in start, and I can drag another one down and put in stop. Okay? And now I can connect the dots. Now notice, if I zoom in, maybe that'll help out. Notice that little dot in the middle? That shows me that this is a Boolean equation. The dashed line shows me that this is a Boolean data type. So if you see a solid line and no dot there, that means it's a real or a dent or an integer. So let me connect the dots there, and you can see this is more visual. And I'll do this output reference. So this is an input reference. This is an output reference, and I can connect the line. And I have this, and this is the equivalent of what I just did. And now I'll download this just to demonstrate. Now these are all memory bits. I might have light one attached to a light. I can't remember. So hit yes. When you see the green around, it means everything's true. Now you'll notice if you have memory bits, you can't like toggle the bit. So what I would recommend is go up to view and show up your watch table. And that will show up down here. And if you want to float it, which I do, this little window will show up. And if I can just put a 0 in there or a 1, and you can see it change. And now if I throw the 1 in there and I hit enter, you can see both will turn on, and it's not associated with a light. so that's what the watch table. I'm gonna take this away. It's over on the other side, but that's a simple Boolean AND. If I want to do a seal in, that makes it a little bit harder. Well, there is a command in here. So let me go offline because it's easier to edit offline. And I'm going to add element, and I'm going to type in reset dominant. These are flip-flops, just like you may have seen before. In this case, the reset, just like a stop button, is going to be dominant over the set. Meaning, if I hit the reset, it turns off the bit, just like a stop button would. So, and again, I could have this set up just like this here. So if I wanted to, I could actually copy and paste this, or I can just go here and draw lines. Now this can get a little confusing, can it? Because you don't know if this is crossing or not. So it is your call. This is what makes function block fun. But again, I can do the reset dominance here, or if I delete that, I could put an input connector here and say light 1 is and draw a line. Or if I'm really feeling interested, I could just put it right in a row and just connect the line directly. So one thing is about function block is I can add the commands in a row. And I can then put in light 1. But how about a reset? Well, let me show something else, because why not? These input references and output references. Okay. Say I got this reset is in another sheet, for instance, or down further down here. I'm going to go way down here, and let's just say A5. Look here how this is labeled A5, kind of like Excel or Battleship. I'm going to add an element, and I'm going to just say a B not. Now, again, there's not. If you look here, not XOR or and. Those are bitwise, meaning it's going to deal with ints and integers and compare the two and pass things through. I would recommend using the BEXOR or BNOTs or band or BOR for your simple like logic gates. So here's my NOT. And what I'm going to do is I'm going to put an input here. And I'm going to say here that this is, I'll do my push buttons over here. So local 1. I'll do on and I'll move this around. Connect the dot. And instead of drawing a line way up here, what I can do is output wire connector. And I can give it a name. I can do reset bit. This is like a temporary tag. It gives me an error because there's nothing there. However, if I go up to here, if I go up to my reset bit and put that in, notice it will show up. Now it will show me, hey, this is situated sheet 1, B5. If I click on it, hey, look, this is associated with sheet 1, B2. And I click, and it'll show me where everything's are. It's a way of cleaning up your program. It still works the same way, except instead of drawing a long line somewhere, or I use the analogy, think of it as like a transporter in Star Trek. This, transmit the information from here to here. So now if I download the program, hit yes. I want you to notice. So there's my errors. I'm going to go my watch. Notice that no matter what I do now, here the light is not on because the reset is dominant. So while this the band command, the and is sending a 1 here to set it, the reset is overriding that. And for me to actually turn this on, I would need to actually physically push the push button because this is a not command. So when this is a 1, it goes to a 0, which then, so the reset goes to 0, which allows things through. Okay. This is a lot more like digital logic gates than it is ladder logic. Okay. So a couple other things of note. Say I want to execute something. So say I have two of these, and I'm gonna go offline. Or here's a good example. Let's say we have a timer. I'm gonna add an element, TOR. Again, I can add more things in here. So if I want to allow the timer to be active only during certain conditions, I can enable the in, and I'll just enable that. Still the same bits, accumulated, enabled, the timer bit, the done. I can allow all those to come out on the back end and maximize that and hit OK. Now they all show up. I can monitor them visually. But in this case, I'm going to go ahead and put another reset bit. I think only one per. So I'll move that down, and I will connect it to there to enable it. So just to demonstrate, say I want my done bit to reset my timer the whole time. Okay, this is a loop. It doesn't know how to execute that. If you right click on the actual wire when it's lit up, you can do this assume data available, which is basically a way of slowing it down so that it allows the thing to execute and kind of delays it from operating. I'm just going to go ahead and put in put this in there, and let me just do a selector switch. That's my selector switch and a preset. I can physically, if I wanted to, I could put in something. I could put in a whole number here. So my preset of 5,000, and it'll take it, and I can draw a line. And notice the difference: solid line versus dashed line. Okay. And I don't have to put anything there, but I can. I'm gonna download. Yes. Go to my watch table. So now notice that this is on, so I can enable the timer. So I will turn the timer on, and now it's timing. And it should automatically reset when it gets to 5 seconds. See, it automatically resets. However, if this reset bit, which is connected to my local data 1, goes to 0, notice the timer stops timing no matter what that switch does. And it resets back to where it was. So this is a way of enabling the rung, or enabling the condition. This is usually hidden, so you would have to go in and hit the 3 little dots in the block properties in order to allow that to be programmed with, because usually it's always enabled. That doesn't have to be there. You can just do everything based upon the timer, enable, just like you would in the ladder logic. But it's another option for you for more flexibility. Two other commands I want to demonstrate, because so there's some Boolean reset. There's your timer. I want to add an element, a CTUD, which is a count up, count down. So instead of in ladder logic, if you wanted, you would need to tag the same timer, go count up on one, and a CTD to count down. You can do all this in one foul swoop, in one setup. So if I do the same setup, go back to here, and I can do the done bit. And so to create the loop there to allow things to run, and I will count up enable, and I'll just do that, and then do, for lack of a better word, that's one thing about function block I don't like. Sometimes the lines get, so there's my count up, count down. A preset, I can go directly in here and set up a preset on the counter. So 5 here, for instance, hit apply, and then download again. I just did the two little switches right there that I use in the program because so to show that this will constantly run in the background. So now if I turn this toggle from should accumulate, notice it's accumulating. If I hit this here, boom, it counts down. So notice that goes 1, this counts down. So it's a way of counting up and counting down. And if I get it all the way up to 5, it should reset. See, it reset it on me. Okay. So one last thing. So this is a count up, count down command. Again, you could put in a reference tag to another timer, another counter, whatever you want there. The last thing I want to demonstrate is this is a scale feature. Maybe you have an analog sensor. So I'm going to add an element, and it's SCL. And you know that you have to change this dynamics from, so if I got a pot here, if it's it could read anywhere from 0 to 3200, or read your technical documentation, for sure. But you want to get that in engineering units or temperature or weight. If you click on the 3 little dots, and I'm going to just go ahead and just highlight these here: raw min, raw max, EU min, EU max. Heck, I can even do min and max alarms here, but I'm going to hold off on that. Hit OK. I can have a value that I read. So let me just do real, like a real value. And notice the data tags here. I'll demonstrate something in a second. I might as well just do it now. I'm going to do local. So my analog is on local 2, input channel 0. I'm going to tie this in here. And what I can do is I can actually physically just put all these in here. And these could be tags on an HMI. They could be just references. I could connect. I'm just doing this just so you can see. I'm connecting the dots. I can go, my raw max would be just like 3100 or 31,000. My raw min is 0. And now say I want to take a temperature between an absolute value or a temperature in Kelvin, degrees Kelvin, where it's 273, it'd be 373, sorry. 373 is max, and 273 is min. I can just go ahead and attach that, and I can put it on an output. This might give me an error, and I'll explain in a second why, but let me just do the basic setup of the scale. And so what this will do is adjust that digital value on the analog into a usable value from HMI or for the operator to understand. Because unless you're Johnny 5, you don't understand binary to be able to convert that stuff in your head. And look, it's automatically working. And if I adjust, I crank my pot all the way up, it's about 370. I could adjust this value so it's a little more accurate. Crank it all the way down, it's at 0. So that is how we scale using the scale feature. Now, one other thing, there's a command called there's a command called an alarm that I can utilize. I can connect the dot right there, and I can have high alarms and low alarms. So in this case, I can go in and I can just say my oh crap, everything's gonna die, we're all gonna die is around 360 degrees Kelvin. My better watch out, we're in the danger zone. Could be 345, and I could say my low limit is watch out, get things running again. Could be like 250. No, it's that way. Sorry. Let's do 300. And we are in deep, deep doo-doo at around maybe 290. Okay. So notice this is the high limit, low limit, low limit. And those could all be alarms that we turn lights to, and I could go in and do lights. So I went ahead and added lights because heck, why not? Go down, download. Go ahead and hide that. And so now if you take a look, both the high alarm and the low alarm are on. Go down a little bit. You can see if you look here, that's a 1, so just the high level alarm is there. I'm in my good zone. Crank it down. You can see that I'm in the issue zone and then the low zone. And all of these, I could, in theory, just click and have those referenced somewhere else. But that hiding them is a way of keeping your programming clean. So those are some fun things you can do with function block. Am I an expert? No, but I can. This is at least gets you a fighting chance. Again, very good process control, very good with some other stuff. I highly recommend you play with it. So thank you and have a great day.